In this sample problem, we will be using the ideal gas law. The problem I am working is from slide 81 on our chapter 11 PowerPoint. And the question states, dinitrogen oxide, N2O, also called laughing gas, is an anesthetic used in dentistry. What is the pressure in atmospheres of 0.35 moles of laughing gas at 22 degrees Celsius in a 5-liter container? So the equation we will be using to solve this problem is the ideal gas law, PV equals nRT, sometimes more affectionately called PIVNRT by chemists. So P is going to be our pressure. Typically, that's in atmospheres, and this problem is specifically asking us to solve for pressure in atmospheres. Volume, which needs to be in units of liters, moles, which are in units of moles, R, which is the ideal gas constant, and depending on your units of pressure can be a different number. In this case, we'll be using 0.0821, and this constant has units of liters times atmospheres over moles times Kelvin. Now that R value, like I said, can change depending on your pressure unit, but since they asked us to solve for atmospheres, we're going to be using 0.0821. And of course, temperature is T, and it needs to be in units of Kelvin. So if we go back to our original question on slide 81, it gives us pretty much all of the variables except for one. It's asking us to solve for pressure. But we're given a volume, we're given a mole amount, we always know our ideal gas constant, and we're also given a temperature. So let's go ahead and write out our known values. So pressure, that's actually our unknown, we don't know that. Volume, in the problem it states 5 liters. Moles, N, it states in the problem is 0.350. Our temperature, it states in the problem, is 22 degrees Celsius. And since we know we're going to be needing it in Kelvin, I'm going to go ahead and convert that by adding 273. That gives me my temperature of 295 Kelvin. And then we always know our ideal gas constant, which is 0.0821, and that is in units of liters times atmospheres over moles times Kelvin. Quite a lot of units, but we'll see that all of the units should cancel out except for our units of pressure, which we're going to be solving for in atmospheres. So now that I have all my knowns written out, I know what I'm solving for. I can go ahead and plug them into the ideal gas law. So pressure, what we're solving for, times volume is equal to our moles times ideal gas constant with the correct units, and that is multiplied by our temperature in Kelvin. So if we look now, we can cancel out moles and moles, Kelvin and Kelvin. That leaves me with units of liters and atmospheres, and once we rearrange everything, our liters should cancel out. We'll be left in units of atmospheres, which is our pressure unit, which is what we're solving for. So we're going to multiply 0.350 times 0.0821 times 295 to get 8.477, and that's in units of liters and atmospheres currently. And we have on our other side our pressure and our volume just hanging out. So to get pressure by itself, I'm going to divide by my volume. both sides. That's going to cancel out liters. And if I do 8.477 divided by 5, it should give me my pressure in units of atmospheres, and I get that pressure is equal to 1.70 atmospheres in this problem. There's your answer.